powered by Reviting, streaming from the Reviting Digital Studio. It's the David Daily. Exploring frontier technology, artificial intelligence, quantum innovation, and the intersection of faith, funding, and the future. Here's your host, David Goki.
Welcome to another episode of the David Daily Show. We are going on 30 episodes strong, and today we have a very special guest with us today, Abhi. And Abhi is the founder of a company. I can't wait to get into it. But since you haven't seen me for some time, we have been on a brief winter hiatus. So if you have had a good holiday, a good brand new year, hopefully the first 2 weeks of the new year are going well for you, and you've been enjoying the holidays and the new year, just like myself and many others watching. So to remind us, we have a couple of main focuses on the David Daily Show. The first is funding updates. Second is our future technology. And we also have the role of faith inside of future technology. So we have guests that have quantum experience, investing experience, and or a faith background. So with funding, faith, and future tech, we have a very special guest today. I'd like to introduce Abhi and bring him to the stage. Abhi, it is so great to have you on the show today. Mr. Chopra, please introduce yourself. Tell us a little bit more about who you are and why you care about all things funding, faith, and future tech.
First of all, thank you, David, for having me on the show. Super excited. Quick background about myself. I'm Abhi Chopra, founder, CEO of BQP, and I am actually an aerospace engineer and a computational scientist by trade. Before this, I used to develop large-scale modeling simulation codes, particularly in computational fluid dynamics, which was like some of the simulations of mine was on Fortran 77 and C, taking 6 months on 250,000 computers. So I asked myself this question, who's this going to be even useful for? Because in industry, we don't perform one simulation. We actually perform 10,000 simulation for each component. So I really wanted to solve the problem of slow and expensive simulation. My first attempt was with Oak Ridge National Lab and NVIDIA, where basically I was bringing these codes from CPUs to GPUs. And in the process, what we found out that even though we got the opportunity to run on the largest supercomputer, we got suboptimal performance improvement purely because of the fact that the algorithms that go behind these tools are outdated and haven't changed in past 40 years. So that's basically what led to me founding BQP. And we have been going strong, I would say, and scaling our company as a seed stage startup now based out of upstate New York, but serving the globe. We have very strong presence in US, in different states, and then also in India. And then there are some European clients that we are serving. What this brings me back to is my beginnings, the humble beginnings, and caring about the world and caring about the planet and caring about the people that we have. So that's how I will tie why I'm excited to be part of this conversation today.
That's wonderful. I really like the first topic, which is quantum-powered flight simulations in aerospace and defense applications, primarily because growing up, my dad actually got a jet propulsion degree from Purdue University, and I built a small website as a young kid on all of the airplanes. We love planes. Some of our family members work at Boeing and are also connected to aerospace engineering world. So yeah, when you talk about flight simulations and quantum powered flight simulations, what does this actually mean? Like if I'm someone tuning in for the first time, wanting to know more about quantum aerospace, where do we even begin?
So I'll begin from the aerospace side first. This and many other heavy engineering fields, they are suffering from this problem where just throwing more silicon to it, more chips to it is not be the solution. And why I say that is because we are trying to go towards, let's say in aerospace, more energy efficient aircrafts. We are trying to go to hydrogen power aircrafts. We are trying to move towards more sustainable aviation in general. But to achieve those goals, I would say there's a very complex engineering process involved. and we rely on our tools, engineering tools, heavily to be able to achieve that. Now, the challenge that is happening in this part of the world is that these tools, as I mentioned in my anecdote, is that these tools are outdated, not because they don't have the best software now in front end, or we don't have access to the biggest and the largest supercomputers. The challenge is more fundamental, where the back end of these tools, where the math and the algorithms live, are outdated and they haven't changed in past 40 years. So that's really the problem that we believe, moving from deterministic world, which is like saying 1 plus 1 is equal to 2, to saying 1 plus 1 has the highest probability of 2, which is the probabilistic world. That's where we are moving towards. And quantum is inherently probabilistic in nature, from its mathematical representation point of view. So that's what we are doing today. We are doing quantum inspired algorithm, which are advanced methods to be able to accelerate these simulations, which can help aerospace companies and engineers. And I can give you a quick example on that of what we have done. The study that we did, I should say, a proof of concept with one of the largest aerospace companies, revealed the fact that there are millions of components in an aircraft. You tend to perform, let's say, 10,000 simulation for each component, but each simulation is taking 1 day to do things. So the math doesn't match there. And that's where the challenge is. How can you solve this problem? Because this goes from a business point of view, where if you are in the early design development stage, you say you do some only like 100 simulations of those components. You go forward to the next stage, where basically you get to the testing and verification, and one of the component fails there. So you have to figure out which of those million components out of which failed, why it failed. So you have to go back again to your early design stage, and this iteration basically leads to, blowing up the deadline and blowing up the budget. And the fundamental way of how we are solving it at BQP is through quantum inspired math, which is existing hardware, no change in the hardware, no change in the front end of software. We are plugging into the back end and speeding this workflow, where by reducing the time for doing one simulation, we can actually enable engineers to feasibly perform those 10,000 simulation, get an accurate answer, make your iterations less, and get to your final product faster. So this affects engineering and the visions that we have in aerospace and defense and the space world and beyond, I would say, to achieve in these heavy engineering industries.
Yeah, I love it. And so, for those of you tuning in for the first time, the focus here is quantum engineering, and more so quantum engineering from an infrastructure perspective, right? Because the infrastructure already exists. In other words, we have computers in data centers. And if you heard Abhi, he mentioned he had a specialty in moving code from the CPU, which is the core processing unit or the central processing unit in a computer, to the GPU, which is a graphical processing unit in the video card. So you have on one side, you have the video card processing all of the heavy lift in terms of mathematics and computation, but you also have the CPU also processing as well. So I want to highlight that key concept in quantum engineering. And the second thing that I also want to highlight is this notion of multiplication, right? This idea that 1 plus 1 no longer equals 2, it equals, 10, right? There's this 10x factor that you get with computing. And so moving to our second point, or our second key topic, which is NVIDIA partnership. I've been waiting for this one. It's such a good one. Tell us, what is NVIDIA in your world, and why does this really matter for your partnership?
Absolutely. So when we are talking about today's quantum infrastructure, and even the future quantum infrastructure, you may be hearing a lot about, oh, the future is going to be quantum. And let me break that myth. It's not going to be. The future is going to be a CPU, a GPU, and a quantum computer in form of a TPU working in tandem. So how do you go from today's data centers, which are HPCs, and how do you add quantum computers to those data centers, and how these machines are going to work in tandem is a challenging problem, and somebody has to solve it. And there are several work going on, but I would say NVIDIA which people know from an AI compute standpoint of view, GPU point of view, has also is working on this intersection of high performance computers and quantum computers point of view, and with their some of their recent announcement. And they have a platform which is called CUDA-Q. So what this platform CUDA-Q does is, and that's where we are working and utilizing that platform with some of our other partners, where we are able to write these new age quantum algorithms on on the machines, and then able to test that in this hybrid infrastructure today on simulators through NVIDIA CUDA-Q. So that's what led to some of our recent announcement, where we are working in our application area of digital engineering, computational fluid dynamics, and digital twin. And that's what we were able to showcase with NVIDIA's CUDA-Q platform, along with our partner Classic, who I would like to also mention, provided the middleware and more efficiency in our algorithm, the target device was CUDA-Q.
Yeah, I love that. So, why did you pick the NVIDIA platform on the back end in terms of first your software as well, when there are so many other competing cloud platforms? And I'm also kind of curious to hear your perspective on how NVIDIA kind of, I guess you could say they leapt into the first number one spot on the New York Stock Exchange. I mean,
Mhm.
surpassing $5 trillion in market capitalization. I mean, they can buy companies for $1 billion like it's pennies now, which is
Mhm.
insane just to see the valuations out there. But I'm curious where you see the technology platform of NVIDIA itself moving forward with other players in this space, these big tech behemoths that can do exactly like you said, just put that quantum computer right next to that other computer unit and that GPU. I mean, obviously you have been in data centers and you understand a lot of this infrastructure yourself, but they're racking these crazy servers that are just a bunch of GPU chips. Now there'll be these quantum processing chips which are able to do a million times more than they were able to do even just 1 year ago. And you have um, this hybrid quantum that's coming out as well, where it's essentially quantum simulations on the hybrid old hardware. So it's very
Mhm.
fascinating, this idea of we'll always have old hardware. How do we really leverage the old hardware well? And so I'm curious how you see NVIDIA being innovative in that way, and why their tech platform, in addition to your other partners, are so important for you.
Absolutely. So I'll first go into the more foundational part of this, as I've highlighted already. So one of the things that is key to understand is quantum computing is not equal to quantum computer. That's one of the myths I like to break. Quantum computing has a whole lot of things inside it, including the mathematics that led to the thought process of quantum computers itself. So there was this field of quantum information science that preceded. And if you look at the mathematics of classical math that we use, these are, we call it tuples, one dimensional list. Whereas quantum, from a mathematical point of view, is going to two-dimensional and three-dimensional, so matrices and tensors, essentially. And when you are able to leverage those quantum math on existing hardware, you can do things today and not waiting for quantum hardware. Now, there's of course an upper limit to how much you can do with it, but there are certain problems that you can exploit today. Now, when you do that, there's always, as you said, there's always your existing hardware. How can you leverage it? And why NVIDIA is able to do it is because of the fact that these quantum computations, once you start to scale up, so you have this quantum inspired and then you have quantum native. So this transition part in the middle requires you to test a lot of your algorithms, and you cannot always run on the quantum computers that you have today from a feasible experimentation point of view. So what you end up doing is you rely on simulators, quantum simulators. So these are basically platforms that help you mimic a quantum computer, but utilizing the compute of what you have today of CPUs and GPUs. Now, why here NVIDIA is playing a role is because these compute, as you start to scale your algorithm up, let's say you want to go from 20 qubit to 25 qubit to 30 qubit to more. And how do you test these algorithms? And that's from our point of view, testing our software is when we require more compute power. And by working with NVIDIA here and their platform, I should say, they're already backing the simulators with the top end GPUs. So it's basically powering through a lot of the things we can test and experiment. And that's the role that, at least from the outside, it seems like NVIDIA is trying to play, where we haven't yet heard any announcement on NVIDIA having their own quantum hardware or quantum chips, but they're playing that key role in the infrastructure play, where through NVIDIA's platform, we can then connect to other quantum hardware. And for companies like us from the software and the application space, that's really strong. And how does this tie to larger picture of why NVIDIA became the top company? Is
Yeah.
because I'll say compute is the new gold. That's where the world lies. Compute is everywhere. It's on your phones, not only your phones and computer. It's on your devices that you wear in your hand, whether it's a watch or a
Right.
ring, to everything else. And NVIDIA is enabling that compute. And I think anybody who's following this space, even from a space side of things, I would say industry point of view, compute is the new gold.
Are you saying compute is the new core?
Is the new gold.
Gold. Compute is the new gold. Yes. Compute
Mhm.
is the new gold. I like that. I like that for many reasons because, yeah, you're exactly right. We have local compute, especially in, call it depreciated hardware, or you have that old cell phone lying around.
Mhm.
That chip's pretty powerful in there. That could be mining you some crypto, or I don't know, whatever you're doing with your compute. But yeah, really like that perspective. I also appreciated that you helped define the difference between quantum computing and quantum coding, or quantum. Um, I think you were saying algorithms,
Computers.
which is really the difference between understanding the hardware that's amplifying the software, but also just the whole mindset, in the sense that now your ID table, your binary tables from a 0 or a 1 perspective can be both and, right? So it's
Mhm.
very interesting. I'll tell you one short story. I remember my very first big Microsoft project, and it
Mhm.
was just one of those, multi-person, six-figure projects. You're just a young kid out of college, and you don't know your left hand from your right hand, or your Excel sheet from your PowerPoint. I mean, you're still figuring it
Mhm.
out, right? And I remember we were working on this project with the developers, and it was an all-night weekender. Like, we have to get this done by Monday morning. And the final thing that fixed all of the code was we just changed all of the ones to zeros in our
Mhm.
ID database. Don't ask me why. I don't know who or what or how, but our data guy was just like, it works. We get the right results. We pass all the test cases. And I'm like, ship it. Please just ship it. Let's go. And
Mhm.
when we decided to ship it with zero equaling true, it everyone had to think outside the box.
Mhm.
That's exactly why I like quantum, especially thinking about getting quantum ready. So, from an infrastructure perspective, how does a company get quantum ready?
I am glad that you asked that question, David, because I've been talking to a lot of the industry leaders on how can they become quantum ready today and not wait for quantum hardware, but actually preempt what they can do when quantum hardware is actually ready soon, which already the timelines are earlier. So here's my take on it. I would say, uh, like I said, there's already enough in the quantum computing world with quantum mathematics and algorithms that exist. And one of the ways you can start, and I'm not saying this is the only way, is with our current solvers, which are quantum inspired, and they are part of existing workflows and tools. So, um, because of quantum inspired algorithms, you can test some of your heavy compute use cases where you are struggling to go and solve an intractable problem. So in engineering, when you look at it, there are several problems. About 78% of the problems in engineering cannot be solved by today's compute, and throwing more silicon is not the answer. We really have to think about efficient algorithms and then utilizing whatever compute we have to extract more. So it's really a throughput case that I'm making here. And one of the ways to go about it is this thought process of quantum inspired, leveraging it, testing it, getting to work with your engineers, getting started with it, and thereby you are understanding what it means to be in the quantum world. And one distinction I would like to make, which I say it everywhere, I heard this from one of the IBM videos, that quantum, don't think of it as a car versus a fast car analogy. Think of as a car versus a boat analogy, where you have to think differently of the same problem, and you have to get into a new way of thinking, and that won't come immediately. You have to train for it. So this is the way where you can be quantum ready today, so that you can best utilize quantum computers once they become part of your data centers along with HPCs. So this is my take on it, and there are several ways to go about it. Like I said, one of the ways is working with us and talking to us and utilizing our
Yeah.
tools. And we are already not only doing for companies, we have actually offered a pilot course in upstate New York, where the students got into quantum mathematics, and they solved supply chain problem, machine learning problems, engineering problems, so on and so forth, in their projects that they did with the tool. So these are just few ways.
Yeah, I love that. In terms of a business getting quantum ready, I really like the sound bit of 78% of problems cannot be solved with quantum, right? 78% of your business technology problems cannot be solved with quantum. So becoming
Sorry,
quantum
David.
inspired, yes.
Sorry, I meant 78% of the problems cannot be solved by current compute, which is the CPUs and GPUs, and that's why there's a big market
Right.
where you have to think quantumly.
Good. Yeah, so we have it here. 78% of problems cannot be solved by quantum computing or by compute.
Mhm.
Right. Yeah. Yeah, that makes total sense. It's often the people, right?
Mhm.
Or even the process, and that's before you even get into technology. If you're a classical consultant, you remember PPT analysis. We call it the PowerPoint analysis, death by PowerPoint slide, before all these AI slide making machines came out. But yeah, it's really interesting in terms of your focus on really the education piece and inspiring through education. IBM recently announced, and actually India announced as well, that they would be investing into 5 million people to become kind of quantum educated and AI educated, if you will, or
Mhm.
technology educated. So that's a huge part of the reason why we have this show, is not just to educate, but to empower and actually elevate individuals in terms of access to knowledge and access to understanding. And of course, we're all still learning AI, but we're also wanting to be quantum inspired and
Mhm.
quantum ready as well. So, kind of closing out this show, by the way, you've been a phenomenal guest. There's been so many incredibly awesome sound bites. You're an excellent communicator and a great teacher as well. It's easy to follow you and listen to your concepts. And you're exactly right. The car versus a boat. If you've driven a car before and you've not driven a boat, you cannot drive your car into the river or the lake or the ocean. You need to learn how to drive the boat as well.
Mhm.
So I really like that mindset shift.
Mhm. Thank you so much, David, and looking forward to having more of these conversation where helping people to understand what really is quantum, and quantum is, like I said, not equal to quantum computers only.
Yeah, exactly. So, what is the best way for people to get connected with you? And if they're interested in working with your business or getting quantum inspired, Abhi, what's the best way to do that?
So if you want to get connected to me, LinkedIn is the best platform for reaching out to me. You can type my name and BQP, and I think you should be able to reach or look at my profile. And if you want to directly connect to BQP, we have our website, bqpsim.com. We are also on LinkedIn, Instagram, X, and other platforms. And we are always happy to have a chat. We are not here to sell you the software only. We are here to help you understand what it means to be quantum ready. So feel free to reach out, and we are always happy to have conversation around quantum and engineering simulations.
Awesome. Well, very exciting. Thank you so much. And I want to invite you to our next segment, Avi,
Mhm.
which is our final anchor segment called Beyond the Bag. So we have funding,
Mhm.
family, faith, and full-time travel. We have future tech, and we have fun. So
Mhm.
I travel often, and you do as well.
Mhm.
Um, and in my Beyond the Bag today, I actually have an LED flashlight here that I got for Christmas. And this is something I just pulled out of my bag here. It's a Type C
Cool.
charger. So you could use it with your laptop to charge. And it comes really handy when you're traveling. Maybe you're on that hike and it starts to get a little bit dark at night, or maybe you're in your hotel room checking out, or maybe you're in a tent, or getting your kids out of the car and you just got to get some light on that little spot. This is nice and handy. It's only about you know I'd say 5 centimeters for our international audience. For us it's like 2 inches, very small. But yeah, it's very good
Mhm.
to have it be on the bag. Now I'm curious, Abby, what is something that you always travel with that's in your bag, in your laptop bag?
So one thing that I always make sure is I have a extra portable charger, an extra one, not just one. This has been an advice given to by one of my advisor that all like you are traveling a lot. You always need to have extra of extra backup of backup. So the one that I really like is my portable charger, and I don't think so. I can travel with it because it's very essential. When you're traveling internationally, sometimes you don't have access to ports or all, or even you're traveling domestically, you're in your car or you're driving or whatever. I think that's for me the most key thing in my travel.
I like that. I have not heard that actually from any of our other guests, a second battery charger. I love that. I will be traveling internationally, and they will have US ports, but yeah, it's nice when you're traveling internationally to foreign countries, and you just need that last 2% of your phone
Mhm.
battery so you can connect to Wi-Fi so you can get that train ticket. I have definitely been there. Well, Abhi, this has been such a pleasure. I'm grateful for this conversation about quantum and quantum inspiration, as well as your NVIDIA partnership. How exciting. And for those, if you're interested, please follow Abhi on all platforms, including LinkedIn. And we're going to sign off here from the show. It was such a wonderful pleasure. All right, see you later.